AB Calculus, Note Card 56, Particular Solutions. This is the 56th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed the Note Card system. Particular Solutions. And we had an introduction to this. If you happen to have seen already Note Card lesson 53 and problem 2, we actually started along those lines. And so here we go full force. To find a particular solution with an initial condition, integrate f of x. So you can have some kind of function. Sometimes you're going to see it as y prime, sometimes dy dx. You could see something at f of x, but these are kind of two common ways. Find y equals f of x using the point x comma y to solve for c. Well, when you integrate, what you're going to have first is something called a general solution. And then after we integrate both sides of the equation to get y equals something, we will be able to solve for the constant of integration c, and then when we find what c is, we plug this value c we found back in to the general solution, at which point this thing is to be called a particular solution. And sometimes this particular solution, I've seen it in other video lessons, called a boundary condition. I like this better, particular solution. So let's go over some problems related to this. Problem 1, find a particular solution of y if y prime equals 3x squared minus 1 and is passing through this point 2 comma 4. Well, this y prime I'm going to rewrite as dy dx. And it's going to be apparent quite soon. So we put the right side up here, squared minus 1. And we are going to cross multiply the dx. And so on the left, we're left with dy is equal to quantity 3x squared minus 1 dx. And what we can do now is integrate both sides of this equation, and then when we do that, we're going to have a y equals equation here. Find y equals f of x. We're going to have a y equals equation. So we're going to do that. To do that, I'm going to just put integral symbols on each side. And what I'm going to do is keep my integral symbol on the left side. And on the right side, I'm going to separate these two terms here. And I'm going to take this 3, using our rules of integration, 3x squared dx minus 1 dx. Okay, and now for the integration, the integral of dy is y, and the integral of x squared is x cubed, and we divide by what we raised the power to, which was 3, and then we have minus the integral of dx is x, and then we have our constant of integration c, and we notice that 3 over 3 will cancel each other, and this equation here is what we call our general solution. So next, we're going to take this point 2 comma 4, and we are going to, let's just see how this works. So in the place of y, we put a 4 here. In the place of x, we place a 2, so we have 2 cubed minus 2 plus c. And so on the right side, we have, left side we have 4, right side we have 8 minus 2, or 6, plus c. So coming to the right here, we will say c is equal to negative 2. So now we have solved for c, and going back to our format here, we solved for c. Now we're going to go to the next step. We're going to take this c and plug it in for this c right here. And when we do that, just to make room, I'm going to go to the left here. We have y is equal to x cubed minus x minus 2. And this is called our particular solution. Because it wasn't until we were taking the data from that point 2, 4 to get specificity to what the particular solution is. Until that, we just had a general solution. Next, 2. For x is greater than 0, find the particular solution of f prime of x equals 3 over x to the 4th power that passes through 1, 2. Again, same strategy. What is that? We're going to change this prime function to dy dx. And that's going to be equal to 3. And what I'm going to do is make an executive decision here. I'm going to rewrite this right side as 3x to the negative 4 power. And now we're going to cross multiply the dx, so we have dy is equal to 3x to the negative 4 power dx. Next, we are going to integrate both sides of the equation, and for that, on the left side we have y, and the right side we have, I'm going to bring this 3 out here. That 3 is a constant. We could have left it out outside the integrand there. We're going to have x to the, now we take this negative 4 power and add 1 to it, so we'll get negative 3, and we divide by what we added. So that's really it, plus our constant integration c. And so just kind of simplifying this, we have y is equal to 3 divided by negative 3 is negative 1. So we have negative 1 over x cubed plus c. And this is called our general solution. Okay, next, we take this point 1, 2, and so that's 1 is our x, 2 is our y. So we put 2 is equal to negative 1, and then we have over 1 cubed plus c. And so really we have 2 equals negative 1 plus c. So if we add 1 to both sides of this equation, we have c is equal to 3. So 3 is what we're going to plug in to our general solution here for c. And again, I'm going to come to the left. We'll say y equals negative 1 over x cubed plus 3. And this is going to be our particular solution. I hope this is making sense. I like this in that this lesson puts together a lot of what we've gone over so far. 3, From an actual AP test, the acceleration of a particle moving along the x-axis at a time t is given by a of t equals 6t minus 2. If the velocity is 25 when t equals 3 and the position is 10, when t equals 1, the position is... So this brings us back to this relationship position, velocity, acceleration. So to get from acceleration to velocity, we need to integrate once. And to get from the next step up to position, we need to integrate again. So what we have here is, just trying to think of the right way to articulate this. We're going to have a of t is equal to v prime of t. And so we're going to write this as dv dt. Okay? And we'll say dv dt is equal to 6t minus 2. And now if we cross multiply the dt, I'm going to bring this to the left a little bit. I'm going to say dv is equal to 26t minus 2 dt. So you know, I hope already what we're going to do next. We're going to take the integral of both sides of this equation. And so for that we get, I'm going to leave this dv here. We're going to get on the right side 6t dt minus 2 dt. And now we're going to integrate. So we get v is equal to 6, and we're going to have t squared, because that's t to the first power, divided by 2. And then we're going to have minus 2t, and we're going to have plus c. Well, what we're going to get here for a general solution is v is equal to 3t squared minus 2t plus c. But we fortunately are given this particular thing here. We know that our velocity is 25 when t equals 3. So I'm going to put 25 is equal to 3 squared minus 2 times 3 plus c. So I'm going to just bring this up here. We have left side 25 equals 3 times 3 squared is 27, and then minus 6 plus c. So it's going to be 25 equals 21 plus c. So subtracting 21, c is equal to 4. So this c that equals 4, we're going to plug it in to this velocity equation here. So we get velocity as a particular solution equals 3t squared minus 2t plus 4. Okay, now next we want to find x of t. So v is the first derivative of position. So v is going to be dx dt. Okay. And that's going to be equal to 3t squared minus 2t plus 4. Now you know what we're going to do now, right? Cross multiply the dt. So dx is equal to quantity 3t squared minus 2t plus 4. And that times dt. So now just integrating both sides of our equation, we have on the left side x is equal to, we have the integral of 3t squared dt minus 2t dt plus 4 integral of dt. And then we're going to have a plus c after we integrate. So let's go ahead and work this out. So we have x is equal to 3. We have t cubed divided by what we raised the power to. So these are going to cancel out here. Minus 2, we have t, and t to the first power plus 1, that's t squared. We divide by 2, so those are going to cancel out. And then we have plus 4t plus c. So this is called, make the room here, we have x is equal to t cubed minus t squared plus 4t plus c. And this is our general solution for position. And it says position is 10 when t equals 1. So we're going to take advantage of that. And so we say this is x of t, right? That's, we're using the same. So I will just change this to x of t just to get our nomenclature the same. So what we're going to get for that is 10 when t is 1, so we have 1 cubed minus 1 squared plus 4 times 1 plus c. So we get 10 is equal to 1 minus 1 plus 4, so 4 plus c. So subtracting 4, c is equal to 6. So plugging that in to our general solution here, we get x of t is equal to t cubed minus t squared plus 4t plus 6. And that's going to be it. So I'll just write it up here. T cubed minus t squared plus 4t plus 6. And unless we had these specific values for velocity and position, we couldn't have done this and gotten the particular solutions in each of those cases. I kind of like this. I hope this has been helpful to you. Good luck, and thanks for viewing.